Hello. So as extra credit, I'm supposed to correct my mistakes on my most recent chemistry test. And let me tell you, they are careless, but I'm here to redeem myself today. So here we go. Here's my first mistake. It's question 2. We're off to a great start. So this question is, a student has a rectangular block. It is 23 centimeters wide, 66 centimeters tall, and 15 centimeters long. It has a mass of 350 grams. What is the density of the block? Will it sink or float or suspend in water? Density equals 1 gram per milliliter. This is my original work for question 2. So I wrote down density's equation, which is density equals mass over volume. We're going to use that in a second. First, I found the volume by multiplying 23 times 66 times 15. I can't read very well backwards. And that was equivalent to 22,770 centimeters cubed because it's length times width times height, which makes it cubed. And then the mass we were already given, which is 350 grams. And then I took the numbers that I found for volume and mass up here that we just found, and I plugged them into the density equation, so that became 350 grams over 22,770 centimeters, and that was equal to 0.01537. So this is where my rounding went wrong. I rounded 0.1537 to 0.154. I thought that it should have been rounded to 3 significant figures because I was comparing it to the mass significant figures, which when you have the volume and mass numbers together, in comparison to 22,000, it has less significant figures. And so I was comparing it to this one. Really, I should have been comparing it to the original numbers that I was given, which are, 23, 66, 15, and each of these all have 2 significant figures, so I should have compared my answer to this instead, and therefore rounded it to 0.015. So that was my first careless mistake. All I had to do was round correctly, so as you can see here, the answer is A, 0.015 grams per centimeters cubed, rather than my answer of 0.0154 grams per centimeters cubed. Unrelated to my mistakes, but as far as will it sink or float or suspend in water, when you compare 0.015 to the density of water, which is 1, I said that it would float because it is significantly smaller than the density of water, which would make sense for it to float. So this is my second mistake. I was supposed to describe how I got the answer to the previous question. My only issue with this question was that in the beginning of my explanation, I didn't describe the concept. I instead said what the question was looking for, basically. So I'm supposed to answer this entire question in order to answer it correctly rather than incorrectly, so I'm going to be reading the correct parts and explaining what I should have said for the incorrect part. So this is the previous question. The density of bismuth is 9.8 grams per centimeters cubed. What volume would a 216 gram sample of bismuth have? And the answer is 22. So rather than explaining what the problem is looking for, I was supposed to explain the concept of the problem, which in this case is the relationship between density, mass, and volume. In this case, we're looking for volume, and we're provided the density and the mass. And when you have out of the 3 of those things, when you have 2 of them, you can find the other. So because we have both density and mass provided to us, we can find volume. So these are my notes for question 8 right here. I set up an equation for volume, which is mass over density, and we were given both of those. So we have 216 grams for the mass, and then 9.8 grams per centimeter for the density. So I have that right here, and then if you divide those, you get 22.04, and if you round that, you get 22. So that was basically what the rest of my question was explaining. I said to find the volume, we can use the formula volume equals mass over density, and because the mass and density are provided, we can just plug in these numbers, and then I explain what I just showed to you. So this is my next issue that I had. It says choose all the terms that would apply to this image, and this image is basically of molecules kind of existing in the same space, and you're supposed to determine if it's heterogeneous versus homogeneous, and if there's compounds or elements present. So my problem here was that I labeled this as a homogeneous mixture rather than a heterogeneous mixture, and I labeled it homogeneous because when I looked at this I thought, you know, if I saw this substance with the naked eye, it probably would look the same throughout because it doesn't seem to be separated enough for it to look heterogeneous. But the answer is heterogeneous because if you look at the gray molecules that are all packed together like that, so that it looks like it's a solid, basically, because they're packed so tightly together. And then the other red molecules that kind of look like water molecules, but just in case they're not, I won't call them that, they appear to be in a liquid or gaseous state rather than solid. And so when you have a mixture of different states of matter, it's considered heterogeneous. And for the other part of the question, I did answer it correctly, but it is one compound and one element because if you look at the red, well, mostly red ones, the size and color of the molecules, components, I guess, they indicate that they're different elements. So the red circle would be one element and the white circles would be a different one. So because they're bonded together like that, they would be considered a compound. And then the element is the gray slabs of whatever solid element that is. And it is one element because they're all the same shape and size and color. So in this next one it says match the description with the appropriate term, and I mismatched the terms law and theory. So here's our notes right here. At the bottom there's descriptions of both laws and theories, and I'm going to read those out loud right now. So for theories, it says, the ideas used to explain our world has different meanings in different contexts and is often used interchangeably with hypothesis, a well-tested idea that has significant data to support it. Theories are not proven or disproven over time, they just get revised as additional information is gathered. And here is what it says for laws. Laws are ideas that always hold true and have never been proven wrong. Laws have a mathematical basis, which means they are often represented by an equation. So based on those definitions, we can see that theory would instead be number 2, which is an explanation that has been tested and verified. And you can also tell that it's that because the definition says that it explains how it happens, and in 3 it says a description based on many observations that predicts what happens but does not explain how. So theory cannot be 3 because it does do explaining of how something happens. And as far as laws go, you can tell that it matches with number 3 because it's an idea that always holds true and has never been proven wrong, and for that to be, it has to be based on many observations, as it says in number 3. And laws do not explain how something happens, so it's just this happens, rather than this is why. So that is why law should be 3 rather than 2. And hypothesis was matched correctly because a hypothesis is basically an educated guess. And in this case, it says a doctor thinks but has not verified that a patient with stomach pain has appendicitis. And he has hypothesized this or made an educated guess because he's a doctor. Based on what symptoms his patient has, he predicts that his patient has appendicitis. So this problem asks, what is the ppm of 677 micrograms of iron ions in 630.4 grams of blood? And I did my math correctly, but what happened was I thought that it said 667 rather than 677, and I'll show you what happened with that. So here's my original notes up here. As you can see, it says 667 rather than 677. And I will explain what math I was doing in the correct version, but basically I did the same exact math, but with the wrong number. So here is my new and correct work. As you can see, it says 677 as it should. So first we start with 677 micrograms, and we changed it to grams, so it is the same unit as the blood sample. So to do that, I used a conversion factor. So as you can see, 1 gram over 1 million micrograms. And to multiply that, you divide a million by 677, and from that I got 0.000677 grams. So now we want to find the mass percent of the solute inside the entire solution, and to do that we take the solute, which is the iron particles, and divide it by the entire solution, which is the 630.4 grams. And we don't add the iron to the bottom here as well, like you don't add it to that, because it is already a part of the entire solution. Because when you think of it, the iron particles are in the red blood cells. So out of this sample, this is already included in this. So when you divide, you get 0.000001.74, and then you multiply that by a million to put it in parts per million. And after you do that, you get 1.073 parts per million. So this is the last problem I got wrong. It was basically the same concept of that I didn't explain the concept of the question rather than explaining what the question is looking for. This is the previous problem that I was supposed to be describing how I got the answer to. So it says, what is the mass in grams of potassium chloride needed for a 20.5 gram solution that is 26.9% of potassium chloride? So here's my work down here. The basic concept of this question is solutions, but in all, we're trying to find the amount of solute that it would take to make a certain solution. So that was the only part of this problem that I got wrong, but I have to explain the rest of the problem. So like I said here, it asks us to find the mass in grams of potassium chloride in a 20.5 gram solution that is made up of 26.9% potassium chloride. So I'm going to read off what I said here and explain if I need to in between. Potassium chloride is the solute in the solution. It's the smaller part of the solution and is what is dissolved into the solvent. We can find the quantity of this because we're provided with the percent of potassium chloride in the solution as well as the size of the solution. The problem is looking for the amount of potassium chloride in the solution in grams. So we start with the solution mass, which is 20.5 grams, and then change the percent that we're given to a conversion factor of 26.9 grams in 100 grams. And then by doing this, we can change the percent present in the solution to a conversion factor. And then I used the conversion factor to find how many grams of potassium are needed to create the specific solution. So 20.5 times 26.9 over 100 equals 5.5145. I can't read it. And I then rounded it to 5.51 grams of potassium chloride. And I rounded it to 5.51 because the smallest amount of sig figs in what I'm given is 3, because 205 is 3. The 0 in between counts because it's sandwiched between two other non-zero numbers.